Hello everybody, how you doing? This is Mr. Dowse. This is, I don't know, probably my 5th or so video going over the Unit 7 review. This is going to be the harder problems on Lesson 7.4 special parallelograms. If you haven't done the easier ones, watch these previous videos. But these are significantly more challenging, I would say. And you're going to see several of these on the test coming up, so it would be very important to understand how to do these. So starting off here, it says find the missing variables and side, angle, or line segments. So first problem is we have a square. It's called FGHJ is a square, FGH and J. And we've got a couple angle measures we need to find, a couple variables, and a side length. Now keep in mind, quadrilateral flowchart is very useful and helpful. So just to remind you that a square has all the properties of parallelograms, rectangles, and rhombuses. So all 7 properties of parallelograms, 2 properties of rectangles, and these 3 properties of rhombuses, all 12 of these. So I'm going to use this to solve several problems here. So we're starting off with angle measures, right? So we have angle F and angle G. So we have these angles in the corners. And I'm going to look specifically at angles on all of these here and see which one might be helpful here. So opposite angles are congruent. That might be helpful. Consecutive angles equal 180. That might be helpful. And then it says for rectangles, all angles are right angles. So in the corner, the angles are right angles. And that's even in the picture here, right? Right angle, right angle, right angle, right angle. That's what I really need to know here. So angle F, this is a 90-degree angle. All of these are 90-degree angles. I mean, that's the whole point of that one property there. So angle F is going to be 90 degrees. And so is angle G, because that's the property we just talked about. Now we need to solve for x. Well, x is over here in this angle, and it says 3x here. So I have that this angle here is 90 degrees. It's also 3x. So I can actually do 3x equals 90, set those equal to each other, divide by 3, and therefore that gets us x is 30. So this x is 30. And then moving on here, we need to find y. Well, y is on these 2 sides here. And then what's special about sides on a square? Well, let's go back to the quadrilateral flowchart and look at sides. So opposite sides are parallel, not going to help me. Opposite sides are congruent. Are those opposite sides? They're not opposite sides, so that's not going to help me. If I keep looking around here, here we go. All sides are congruent. That's the property of a rhombus. So all the sides are congruent, and if you look at the picture for squares, all these sides are congruent. So I know that, let's change colors here, this side and this side are going to be congruent to each other. So that's the math here. I can set 15y plus 2 equal to 11y plus 10. And the goal is to solve for y. And then once I know y, we can plug it back in to find the length of JH. So I'm going to subtract 11y from both sides. So I get what? 4y plus 2 equals 10. I'm going to subtract 2 from both sides. I get 4y equals 8. Divide both sides by 4 here, and I get y is 2. That's nice. Let's check our answer here. Let's plug 2 back into GH, plug it into this one as well, FJ, and see if they balance out. If so, we know we did it right. So let's do 11 times 2 plus 10. And we'll do 15 times 2 plus 2. Well, what's 11 times 2? That's 22. What's 22 plus 10? That's 32. Same thing over here. What's 15 times 2? That's 30. What's 30 plus 2? That's 32. So since these balance out, you know that y has to be 2. And also we found out with JH's, that is a length of 32. And so that's how you solve number 23 involving squares. Number 24, next one. It says RSTU is a rectangle. So RSTU is a rectangle. So again, on a parallelograms, we have, for rectangles, we have the 2 properties here for rectangles plus these 7. So there's 9 properties that are going to be useful on this problem. So let's see here. We've got angle RST. So if you trace your pen or pencil over RST from R to S to T, we need to find out what that angle measure is. So what's special about angles on a rectangle? Let's see what we got here. So opposite angles are congruent. That's not going to be helpful right now. Consecutive angles equal 180. That might be helpful in a little while. But is this one right here, all angles are right angles, so right angle, right angle, right angle, right angle. So this is going to be a right angle. So this is 90 degrees. So that is a 90-degree angle. Now it asks to find angle URS, from U to R to S. So U to R to S. This angle, again, also going to be 90 degrees because all these angles are 90 degrees in a rectangle. Same thing for the square, right? So this is a 90-degree angle. So hopefully those weren't too challenging. Now we need to deal with x. Solve for x. And we have all these segments or sides defined, whatever those are. So x is on the diagonals. So it's not on the angles, it's not on the sides, it's on the diagonals here. So I'm going to look under the properties under diagonals and see which one of these is going to be helpful here. So here we go. Diagonals bisect each other. That might be helpful. Diagonals divide this into the parallelogram into two congruent triangles. That might be helpful. And then it says diagonals are congruent. So we've got three of them here, right? Let's look at the first one here. Diagonals bisect each other. So what does that mean? That means that this diagonal RT is bisecting this diagonal US. So we know that this segment and this segment are going to be equal to each other because this diagonal is cutting this one in half, but it's going the other way around as well. Diagonal US is cutting RT into two equal segments, so I know that RM and MT must be congruent to each other. So that's the property that I need to know, right? I need to set those values equal to each other. 4x plus 7 equals 6x minus 1. From here, solve for x, so take away 4x from both sides. 7 equals, what is that, 2x minus 1. I add 1 to both sides, and I get 8 equals 2x. Divide by 2, and I have x as 4. So I'm pretty sure that's right. Again, I always like to check my answers by plugging these values back in. So if I were to plug a 4 in for x here, so 4 times 4 plus 7, we also have 6 times 4 minus 1. 4 times 4 is 16. 16 plus 7 is 23. And then 6 times 4 is 24. Minus 1 is also 23. So that's a way to verify that x is 4. We just kind of plug it in and see if it balances out the equation. And that actually gets us some of the next problems here. We need to find what RM is. Well, this part of the segment we found out to be 23. Interesting. We'll get to that one if we need to. And then we have RT. RT is from R to T here. That's the 23 plus the 23. That is 46. So that would be the answer on that one. It's this here that I need to figure out. So we actually read a property that was going to be helpful here. So it was this bottom one here, that diagonals are congruent. So that means from R to T, this diagonal RT is congruent. Is congruent to the diagonal US. So those two lengths here are going to be congruent to each other. Since the segments are congruent, these lengths are congruent. And so not only that, since they're bisecting each other, all these segments are congruent. So if this is 23 and this is 23, this would also be 23, and so is this one. That's a unique property that rectangles and squares have. The diagonals not only bisect each other, they're also equal to each other. So all these little segments here are going to be congruent, so they're all 23. That means that has to be 23 as well. Moving on to number 25. And in my opinion, this is probably the trickiest one of all on this whole page. So hopefully it doesn't take too long, but I might have to stop the video after this one and start up another one. We'll see how long it takes. So we have a rhombus here. So a rhombus, let's see what we got here. So I'm going to look at properties. Now first of all, x, y, and z are dealing with angles here. And then this is dealing with angles here as well. So I'm going to look specifically under the parallelogram and rhombus properties for angles, right? So this says opposite angles are congruent. That's going to be useful. Consecutive angles equal 180. That might be useful. And it says diagonals are perpendicular. This is saying that the diagonals are crossing each other at a right angle. That might be useful. And this is diagonals bisect opposite angles. That's going to be useful. So there's at least 4 properties here that we can use with angles. And I'm going to focus specifically on this one first. Diagonals are perpendicular. So diagonal AC and diagonal DB are hitting each other at a right angle. So all these angles here are 90 degrees. So I know that x has to be 90 degrees. That's helpful. And this is properties for rhombuses and squares, since squares have the properties of rhombuses. So keep in mind here, this is 90 degrees right there in the middle. So what else do we have here? Let's see here. Diagonals bisect opposite angles. That's going to be useful. So that means, that, like for example, let's say we have a rhombus here. Let's say this angle was 80 degrees, and this is 80 degrees because, again, opposite angles are congruent. If we were to draw a diagonal here, it means it's cutting these two 80s into 40-degree angles. It's cutting them in half, right? So we'd have a 40, a 40, a 40, and a 40. These aren't 80-degree angles. I don't know that right now. I'm just telling you that's what this property means. So if we have diagonals bisect opposite angles, I know that this angle and this angle must be equal to each other. And that goes along the lines of the lines of symmetry that we have for rhombuses. The diagonals are the lines of symmetry. So if you were to fold the left half of this rhombus over the right half, these two angles would match up, these angles match up, these angles match up, so do these, and so do these. Well, there's another line of symmetry here in a rhombus. It's the other diagonal, and that means the top half of the rhombus and the bottom half would match up. So again, Z and this angle would be the same. These are both 90, both 90. These two would be the same as well. So that's, again, you can either look at the diagonals bisect opposite angles or remember the lines of symmetry to understand how we solve for y here. So I'm going to set those equal, right? We have 5y plus 2 equals 7y minus 14. I'm going to solve for y now by subtracting 5y from both sides. And I have 2 equals 2y minus 14. I'm going to add 14 to both sides. And I get 16 equals 2y. And then I'm going to divide by 2 here. And y is equal to 8. And I'm going to plug that back in just to check it. So we have 5 times 8, which is 40 plus 2. That's 42 degrees. And then 7, so 7 times 8 minus 14. Let's double check this here. Instead of doing it by head, 7 times 8 minus 14 gets me also 42. So this one also equals 42. So that's just a real quick and easy way to check and make sure that, y is 8. And we're going to need to do this anyways, which is why I did it, because we need to find z and all these other angles. So now that we have what y is and what these angles are, remember we have lines of symmetry here, right? So I can reflect these angles across here. So if these are 42 degrees, so would these be. And then from there, we have a triangle. And what do triangles add up to? These three angles, the 42, the 90, and the z, they have to equal 180 degrees. So if I add the two angles that we have, the 90 and the 42, I'm running out of space here. We'll do 90 plus 42, gets me 132. Take that away from 180. I get 48 degrees, so z has to be 48 degrees. Now again, lines of symmetry here. This angle and this angle are going to be the same, so they're also 48 degrees. And then those two would reflect down here as well, because again, line of symmetry here. Those two are 48, so would these. And that's going to be useful to find these last two angle measures. So lastly, we need to figure out what is the measure of angle ABC. So if I pull out a highlighter, go from A to B to C, we want to know what is that entire angle measure. Well, we know parts of that. We know the two 42s here. So if I add those two together, 42 plus 42, that gets me an 86 degree angle. So these combine to be 86 degrees. And so same over here, right? These would be 86 because opposite angles have to be congruent. Oops, not 86. That's 84. Sorry about that. Sorry. So these would be 84, these would be 84, so opposite angles are congruent. And then lastly, we have angle BCD, from B to C to D. We want to know what that entire angle measure is. And we had a 48 here until I covered it over. So if I add the two 48s, 48 plus 48, that would get you 96 degrees. And so we finished this problem out. So again, these would be 96 as well, so opposite angles would be congruent. And then if you add the 84 and 96, you get them to be supplementary, they equal 180. Another way to kind of confirm that you did this right. I am going to do just one more problem here. It's not going to take very long to do 26, so let's just kind of wrap this up. I know it's a long video, but I'm sorry. So FPWK is a parallelogram. So on this particular problem, There are only 7 properties we're going to focus on, right? All 7 under parallelogram. So this is not a rectangle, not a rhombus, not a square. So we can ignore all these properties down there. So this is focusing specifically on angles that are opposite of each other. And what do we know about opposite angles on a parallelogram? We know that they are congruent. So I know that this angle and this angle must equal each other. So I'm going to set them equal, right? We're going to have, what is it, 8x minus 5 equals 6x plus 13. Just going to solve for x here by subtracting 6x. So I get 2x minus 5 equals 13. I'm going to add 5 to both of these, and I get 2x equals 18. And I divide by 2, and x is 9. And then now it wants us to find angle P and angle F. Well, of those two, angle F would be a lot easier because I know what x is. It's 9. So we're going to do 8 times 9 minus 5. So if I do 8 times 9 minus 5, I get a 67-degree angle. If you do the same thing down here for angle W, what is that? 6 times 9 plus 13, also get 67. So again, we know that x must be correct then. And then what's special about like F and P? Well, those angles are consecutive angles. They're angles that are right next to each other, and we know those must equal 180 degrees. So I know that these two must equal 180. So if I take away 67 from 180, I get 113 degrees. That is angle P. So just double check that. 180 minus 67 gets me 113 degrees. And that gets me the last answer to the last problem I'm going to do in this video. So hopefully this helps you out. Otherwise, have a good day, and I'll see you later. Bye-bye.